Good day, everyone. You are once welcome again back to Algebra Academy channel. And this time around, we'll be looking at an important part of physics that concerns both JAM students and undergraduate students. Because you can find this topic as one of the prominent topic as far as JAM is concerned. And we also have undergraduate students also doing this topic as one of the topics of the course they offer in school. Especially University of Ilorin students, they have this topic in Physics 101. And I've received a lot of tags and DMs concerning the topic, which is it's even a subtopic under motion, particle kinematics. Particle kinematics. So in particle kinematics, we'll be looking at some things, but I won't go there yet. This particular question on the screen is what I received, that I should solve it for particle kinematics. And as a matter of fact, this question is not from particle kinematics. This question is not from particle kinematics. It is from vector, because you can see the expression of velocity in vector form, 3i plus 4j. This is unit vector. So this question is not from particle kinematics, although I'm still going to solve it and bring an example from particle kinematics to clarify the difference between the two. Now let's solve this question first. Solution. We have been given velocity v to be equals to 3i plus 4j in meter per second. Now we're asked to calculate speed. Now, what is the difference between speed and velocity? Speed, it's a scalar quantity, while velocity is a vector quantity. Now, in terms of magnitude, they are supposed to have the same magnitude in terms of magnitude for the two of them. Now, for this question now, we have been given the resultant of the velocity, which will be the same thing with speed in terms of magnitude. Like I said earlier, the two of them will have the same magnitude, but in terms of direction, it will be different. Now, this is what the question is asking us to do. We should calculate the speed from velocity. So we're going to calculate the magnitude of this vector. Whatever we get for the magnitude of this vector also represents speed. How are we going to calculate magnitude from vector? Magnitude is just finding when you have v is equals to 3i plus 4j like this. What you're going to do is you square this resultant, and you find the square root of all the resultant, and you square each component like that. Then when you're doing that, you remove these directions because you are looking for magnitude. Direction is not important. So you're going to have it to be 3 square plus 4 square. Their square root. 3 square is 9, while 4 square is 16. Square root, if you calculate very well, it's going to be root of 25. The answer is 5 meter per second. This is our speed. So this question is not from particle kinematics, it's from scalar and vector. So that's just. Now this second question is a question from particle kinematics proper. So the question reads that the velocity of a particle moving along a straight line is v is equals to t squared plus 2t in meter per second. That is the unit of velocity. If its position s is equals to 0, when time t is equals to 0. Now we're asked to determine its acceleration and position when time t is equals to 4. Now, what will make you identify particle kinematics is that the expression of position, they may use letter X or S to denote position, or velocity, or acceleration. These three are what we should study in particle kinematics. The changes that occur between displacement, or sometimes they call it position, velocity, and acceleration. The changes that exist between the three is what we refer to as particle kinematics. How we change from velocity to acceleration, or from displacement to velocity to acceleration. Now, we can change in three ways. It is either you are coming down like this. That means you are coming from displacement to velocity to acceleration, or you are moving up. That means you are changing from acceleration to velocity to displacement. The two changes are different in terms of operation. When you are coming from velocity, sorry, when you're coming from displacement to velocity to acceleration, it's as if you are going higher because you are going from a lower quantity to a higher quantity. You differentiate. Differentiate. The operation is differentiation when you are coming down. When you are moving up, the operation is integration. Integration. Now, how do you differentiate and integrate? I'm going to explain and give you a shortcut. Now, what are you differentiating? What are you integrating? Number one thing that we even let you know that this question is from particle kinematics is that the expression of either your displacement or velocity or acceleration will be in a quadratic equation form. You can see this look like a quadratic equation. The moment that expression of either displacement, velocity, or acceleration is in form of quadratic equation, then it is from particle kinematics. Now, let us look at the solution of this. Solution now. In this question, we're given velocity. They were asked to calculate acceleration and position, which is also displacement. That means we are here now. We are in velocity. We are going to acceleration, whereas we are going to displacement. So you are going down, we are also going up. So the two direction of movement is what is going on in this particular question. We are given velocity, we are coming down to calculate acceleration. It means we will differentiate, then we'll also integrate. So let me write out the question. We have V to be equals to t squared plus 2t. Now, let's get acceleration first. To get our acceleration from velocity, which is dv over dt, we are going to differentiate. We differentiate each of these quantity. We differentiate t squared. To differentiate t squared now, according to mathematics, the shortcut t squared, we are going to subtract 1 from the power. Then we use that power to multiply the whole function. We subtract 1 from the power, then use that power to multiply the whole function. That's for the first one. For the second one, which is 2t, 2t is also 2t raised to power 1. We subtract 1 from the power, 1 minus 1, and we use that one to multiply the whole function. Then we have this to be 2t from 3 squared to reduce to 2t, because when you subtract 1 from 3, it is 1. 2t. This will be 1 because it is 1, it is plus, this is t raised to power 0. 2t is 2t raised to power 0, 1 multiplied by 0, everything becomes 1. So when you differentiate 2t, you are going to get 1 plus 1 like this. So our acceleration A now is equals to 2t plus 1. That's our acceleration. Sorry, this is supposed to be 2, not 1. 2, not 1. Because it is t raised to power 1 minus 1, which is t raised to power 0. Anything raised to power 0 in mathematics, it is 1. 2 multiplied by 1 is 2. 2 multiplied by 1 to this side is also 2. So our acceleration is equals to 2t plus 2. Now at time t is equals to 4, that means anywhere we have t here, we substitute 4. We have A to be equals to 2 bracket 4 plus 2. So 2 bracket 4 is equals to 8 plus 2. So everything gives us 10 meter per second square. That's our acceleration. Now to get displacement, which is position, we are going to integrate. You know, in this we differentiated because we are going to acceleration. Now we are going to integrate this time around. What are we integrating? We are still integrating what we are given in the question, which is velocity. So V is equals to t squared plus 2t. How do you integrate? Differentiation, you subtract 1. Integration, you add 1. So we're going to have t raised to power 2 plus 1. That power that you now have, that new power that you now have, you bring it as denominator. 2 plus 1, you bring it down again. Plus, you are done with that. So for the second one, which is 2t, 2t now is 1, is 2t raised to power 1. So you add 1 to it. Then you bring that one also as denominator, 1 plus 1. So we're going to have our, it is no longer V now, it is now X or S, because we have changed everything to displacement. We have integrated. So we're going to have our displacement now to be equals to t raised to power 3 divided by 3, because this will be 3, this will be 3, plus 2t squared over 2. 2t squared divided by 2. So for these t, 2 cancel 2. So we're going to have it as t raised to power 3 divided by 3 plus t squared. So this is our displacement. At time t is equals to 4. At time t is equals to 4, we're going to substitute 4 into anywhere we have t. So our x or s, they can use any of this letter to denote displacement, will be equals to 4 raised to power 3 divided by 3 plus 4 square. So everything here will give us 48 rather. 48 divided by 3 plus 16. So our answer will be 16 meter. Or is this 16? Sorry, 16 plus 16 meter, because 3 here 1, 3 here will be 16. 16 plus 16, which is 32 meters. That's our displacement. So this is how to calculate particle kinematics. And this question, once again, is not from particle kinematics, it's from unit vector. Why this is a standard question for particle kinematics? If you have any question that concerns particle kinematics, you can't handle it, you can send to the comment section. Thank you.